All right. Okay, so I got everything situated. We're going to go ahead and get started. So very quickly, let me go ahead and let you know what's happening over the end of this week, going into next week. So remember, I did show you this calendar earlier. Okay, so we are right now Thursday the 1st. We finished up the natural number yesterday, but there are a few examples that I want to go ahead and take a look at just to kind of wrap that up. That's okay. Okay, so we're going to go ahead and wrap up the natural number very quickly. Then we're going to go ahead and start compound interest. And remember, earlier in the week, I gave you the assignment for exponential equations. We're going to solve those using logarithms. And then yesterday, I went ahead and gave you the natural number assignment. So we're going to go ahead and talk about both of those tomorrow. Now, on Monday of next week, we're going to have our next quiz. So that's going to be solving exponential equations using logarithms. Okay. So after that, we'll finish up compound interest. We'll move into parabolas. That'll take all of next week. And then on Tuesday the 13th, that's when we go ahead and take our post test. So we are good to go. Now, I'm hoping that parabolas is not going to take me as long as I'm thinking. With whatever extra days we have, I'm already putting some packets together, one for quadratics, factoring, systems, things we haven't talked about in a while that will most likely show up on the post test. But are there any questions? Because that's when we're taking the exam. Yay! Because you get happy when you think of math, right? The post test. Yes. It's all right. It's all right. It's okay. See, that's why we cover this daily, just in case. Okay, so I believe we finished up yesterday. I asked you to go ahead and try number 18, where we were solving this equation with the natural base. Okay. So this one right here. Okay, so x should have come out to 9,869.70. Or if you said 0.69, I mean, that's fine. Okay. All right. Did anybody happen to get that answer for number 18? If not, that's okay. We're going to go ahead and talk about it. All right. So remember, e is our natural number, okay? When it's a base and an exponential, then it's going to be a growth base because it's 2.71828, definitely greater than 1. Now, if we use base e in a log, that's what we call the natural log, and we have the notation, ln of x. So this is going to be base e. Okay. Now, just like we saw yesterday, a few of these problems, including number 18, we're going to have to condense one side before we go ahead and do anything. Okay, so what do we do with logs of the same base that are separated by subtraction? We divide. So because x is first, that means it has to be in the numerator. So I'm going to say the natural log of x over 9 is equal to 7. Now, we've been working lately with equations where it's a 1 log equals a second log. If that's the case, we just cut the logs loose, but this one only has the 1 log. So what did we do yesterday? There we go. We go ahead and convert it. Okay, so this is going to be base e to the 7th is equal to x over 9. Now, we'll worry about e to the 7th in just a second. How would I solve this for x? How would I get rid of that 9? Yeah, I just multiply through by 9. Okay, so I'm going to end up with 9 times e to the 7th power equals, when I distribute, the 9s are going to cancel. There's my x. So I can just go ahead and plug this directly in the calculator. So let's see what we got here. I'm going to come on over. 9. Remember, over on the left side, you got the button e to the x. If you hit control on that button, that brings up the natural log. And we want e to the 7th. So there we go. Now, this one, if you ever want to see decimals beyond what it rounds, see, that's why I said, if you put 0.69, that's fine. But with that 0.698, the 69 rounds to 70, so that's why I said 0.70. But I'm not going to split hairs on the decimal values. Okay, questions? Yeah. Now, even if you put the 9 after, that should be okay. You just want to make sure it's not in the power. So let me show you what I mean. So let me go ahead and push enter again. So let's say e to the 7th. See, now my cursor is still in that power, so I'm going to go ahead, make sure it's not, times 9. Still going to give me the same answer. What, did you get something different? Or let's try, maybe this is the idea. So maybe e to the 7 times 9. Is that what you got? No? Something like that. Did it have e? Okay. In fact, does anybody recognize that e? Does anybody know what that means? It's a type of notation. It starts with an S. Scientific notation, yes. Where you had to have like a number times 10 to the power, and that would tell you how to move the decimal. Okay. That's exactly what this is in the calculator. Okay. Well, cool. Well, maybe when we finish, remind me. I'll take a look at it. We'll see what I can do to help you out. All right. So we have 4 questions left. Are there any of those that you're looking at and you're thinking, I'm not sure how I would solve that? $21? Okay. So 5 times e to the 4n equals 95. Okay. Now it is an exponential. Okay. It is not isolated though. What do I have to get rid of before I can convert? The 5. So I need to go ahead and divide through by the 5. Okay. So this is going to be e to the power of 4n. I need a 95 divided by 5. 19. Okay. And now this is the same style problem that we were just looking at. Okay. Instead of going from a log to an exponential, now we're going to go from an exponential to a log. Okay. So it's base e, so that's the natural log of what? 19. And what should that equal? 4n. Okay, because remember, a log is a power. Even a natural log, it's still a power. So whatever power you have, that's what it has to equal. All right, so how would I solve this for n? What would you do? Just divide by 4. Yeah. Okay. So now I'm going to turn my attention to the calculator. I'm going to go ahead and type in exactly what I've got. So I would do it like this. Okay. I like to go ahead and hit Control Divide if I've got a fractional value. So up top, I'm going to hit Control e to the x. This was the natural log of, and I forgot the number, 19. Okay. That's not what I wanted. And then we're going to divide that by 4. So the natural log of 19 divided by 4, I'm getting that n should be, let's say, 0.74. Now remember, what I'm about to show you now, this applies, and I believe I've shown you this before, but it can be used if you're maybe trying to solve a quadratic or a rational function, exponential, logarithmic, whatever. Let's say you don't remember how to do it, by hand, which is perfectly fine. Let's go ahead and take one that we've already worked. Like, let's go back to number 18. Okay. Let's say I want to go ahead and have the calculator solve this for me. Okay, so one, I could do it graphically. Let me go ahead and make sure I have this because I'm going to forget it. Okay, so what I want to do is take the left side of the equation and I want to go ahead and graph it. So over here on my calculator, I'm going to go ahead and say Control e to the x. What was this? The natural log of x, and then minus the natural log of 9. Okay, so that's the left side of the equation. So I'm going to go ahead and push enter. Okay, and then I'm going to go ahead and set this equal to 7. So I'm going to go ahead and say tab 7. Okay. Now 7 is going to be up here, so I can go ahead and change my menu. Now what we're looking for is where they intersect. Okay. Sometimes it's going to be easy to find. This one is going to be well off the screen because remember the answer was 9,869. So let's do this. Let's go to my window. I like to go to window settings. Okay. So we got to let's go ahead and put 10,000. So let's go 0, 10,000. And then the height is 7. So let's go between 0 and, let's say, 10. Let's see how that works out. Okay. So right here is that intersection. That's what I want. Okay. So it takes a little while to get there on this problem. Not every one of them. You know, this one happens to be unusual. But if I go to menu, what are the keystrokes? Okay, so we want to choose Analyze Graph. Then we're looking for the intersection. So remember, lower bound. If I'm looking for this right here, I put it to the left of where I want it. Upper bound means the right. There you go. See, there's that scientific notation again, telling me to go ahead and move the decimal point 3 places to the right. Okay. Now, there is also another one on here. I don't know how well it'll work. Let's choose another problem. Maybe this will work. Let's try it. Document B. All right. So let's try number 17. Okay. Let's say we don't want to go ahead and graph it. Let's try this. Menu. Now, if this feature is still available on your calculator, okay, go to Algebra, Numerical Solve. Let's just try to type in the equation. So we're on number 17, the natural log of 8x, okay, equals is right down here at the, right here in the middle, okay, and then what does it equal? 2. Now, if you're going to go ahead and use this, at the very end, you have to put a comma and then tell it what to solve for. I have shown you that before, right? I thought so. Remember, you're going to have the calculator on that post test, so yeah, absolutely. You know, take full advantage of it. Absolutely. Okay. But let me go ahead and get back over here. Were there any other problems you wanted to do? How are we feeling about the natural number? Is it coming naturally? I cracked myself. What's up? Okay, well then let's go ahead and put that to the side. Okay, we'll go ahead and talk about that assignment tomorrow. We'll run through a few problems. We are now on compound interest. Okay. All right, so it's going to look like this. Okay, so exponential growth occurs when a quantity exponentially increases over time. Here's our formula. So we have a times 1 plus r to the power t, where a is the initial amount. That's the amount that I'm going to start with. Okay, r is my growth rate. That's always a percentage. And then t is going to be the time. Okay, and typically we go ahead and look at this in years. Okay. All right. So all we're wanting to do is look at a word problem. We're going to go ahead and plug in the appropriate information and then just answer the question. Okay. So let me show you how easy this is. Number one, the original value of an investment is $1,800. If the value is increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. Okay. Well, let's go ahead and identify all the pieces. I'm looking for an A, an R, and a T. Okay. Well, what's the initial amount? What's A? What's the amount of money that we're starting with? 1,800. Okay, so that's the initial amount. What's my percentage? 7%, so that's my R. And then 15 years, that's my time T. Okay. Now I'm going to go ahead and write the function before we go ahead and solve it. So f of t is equal to, well, A is 1,800 times. Now, we need to go ahead when we're working with a decimal, we want to go, when we're working with a percentage, we want to change it to a decimal. Okay, so that would be 0.07. So my actual R here is going to be 0.07. 007. We all know James Bond, right? No. No? Dun, 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 dun. Shaken, not stirred. I've got a license to kill. I'm trying to do a Scottish accent. It's not coming through. Okay. All right. Well, there we go. So in this particular one right here, I would have 1 plus 0.07 to the power of t. See, if your value happens to be increasing, well, then you're going to add your percentage. In a moment, we're going to start looking at problems where the value will decrease, hence you're going to subtract your percentage. Okay. All right, so what is a 1 plus a 0.07? Yeah, so 1800 times 1.07. So there's my function. Okay. All right. Now it wants me to answer the question, well, what's the value of the investment going to be after 15 years? Well, this is where I just go ahead and take my number of years and I plug it in. So f of 15 is going to equal 1800 times 1.07 to the 15th power. So once you get it all set up, really this is just substitution. Then you let the calculator take over. So I'm going to come on over here. Okay, so I have 1800 times 1.07. And then we're going to raise that to the 15th power. So I'm going to go ahead and push enter. Now, we're talking about money. So how many decimal places do you think I should take? 2, yeah, for the change. Okay, so $4,966.26. So 4966.26. And then you kind of get to an idea of whether this is going to be worth it or not. You started with 1800 and it took 15 years to go to this. I don't think that's really good. I mean, that really is a good interest rate, but you got to do a little more. In fact, unfortunately, nowadays, especially with the way the economy, the way it is, you probably won't even get a 1% interest rate. It's going to be less than that. Oh yeah, it's going to be pretty low. Because when you think about it in the grand scale, I mean, what is a bank? It's a business, right? They don't just hold your money. Once you go ahead and invest with them, what do they then take your money and do? They invest it in other stuff because they're trying to make money for the bank. And, they try to give you incentives to get you to come in and things like that. I will go ahead and say that, at some point, make sure that you do have a bank account that's FDIC insured so that in case anything happens to the bank, you still have your money. But what I would say is, if at all possible, if you can compound continuously, that is the best deal you'll ever get. Okay. Yeah. Oh, it's the number of settings. It's just showing you more decimal places. But you see the 0.256 would still be 0.26. Okay. Well, that's not too bad, right? Okay. Well, let's go ahead and try number 2. In 2002, there were 972 students enrolled in Oakview High School. Since then, the number of students has increased by 1.5% each year. Write an exponential function to model the situation. Then find the number of students enrolled in 2014. Okay. So let's go ahead and identify what we've got so far. Do we have an initial amount? Yes, what is it? So we're starting with 972 students. That's my A. Okay. What's my interest rate? Okay, so 1.5%. Now remember, we've got to go ahead and convert that to a decimal, and I know what you're thinking, well, it's already got a decimal, but remember, we don't want the percentage. It has to be the decimal that we're going to compute with. There we go. So it's going to be 0.015. If you're going to convert a percentage to a decimal, you move the decimal point 2 places to the left. If you want to take a decimal and make it a percentage, you move the decimal 2 places to the right. Okay. I mean, it'll take a little bit, but you'll get the point. It was the point, the decimal point. You'll laugh later. I got you. Okay. And they don't immediately give me T, but they give me enough to find out. Anybody tell me what it is? Yeah. So the time is going to be, we want to know what's happening in 2014, but we started this in 2002. So that means we're looking for 12 years. Okay. So let's go ahead and fill it in. Here was my general formula. F of t is equal to A times 1 plus R to the power of t. Okay. So F of t is equal to, we were starting with 972 students. Now I need to take 1 and add 0.015. Well, that's easy. That's just going to be 1.015. And then to the power of t. So there's my function that's going to be able to answer my question. Okay. Do you remember doing this maybe back in Algebra 1? Does that seem kind of familiar? Okay, a little bit. Okay. So now let's go ahead and see how many students we're dealing with 12 years later. So 972 times 1.015, and we're going to raise it to the power of 12. Okay, so I'm back over here to my calculator. So 972 times 1.015 to the power of 12. Okay, who can tell me what I should get when I push enter? Okay. Now, this is also where you want to start asking yourself, is my answer reasonable? Now, in the previous example, a decimal was reasonable because we're talking about currency, right? Well, here we're talking about what? We're talking about people. So you don't have a portion of a person. So in this case here, well, I mean, you could. It's going to be gross, but we're not going to go down that path. Okay. Even if someone's missing an arm, they're still a whole person, right? I mean, you probably got to hand it to them, but Oh, come on. Oh, come on. That was bad. That was bad. I shouldn't have said that. Okay. On a problem like this, you wouldn't put a decimal, so I would probably go ahead and say 1,162 people. Okay. 1,000. I'm not going to make any more jokes. Not about that. And you know what? There are people who will make an argument that even if you have a percentage, not percentage, but a decimal, like in this case, it was 0.14, even with any portion of the decimal, you can still go ahead and round up. I actually see both sides of it. So in something like this, if you were to go ahead and give me 62 or even 63, I'm not going to split hairs on that. I mean, because you're already demonstrating that you understand, how to get to the answer and set it up. So I'm not going to put, I put 62 and you put 63, so it's wrong. Yeah. Okay, so what do we think so far? So that's exponential growth. Yeah, got you back. Okay. Well, let's go ahead and look at the other side of that coin, exponential decay. So this occurs when quantity exponentially decreases over time. All right, so we have the same formula, except what's the difference? There's one key difference. There you go. Because it's a decay, you're not adding the percentage rate, you're going to be subtracting it. Okay, so A is still the initial amount, T is still your time, but R in this case represents your decay rate, that percentage. Okay, well, let's try one. An investment of $12,000 is losing value at a rate of 4% each year. Write an exponential function to model the situation, then find the value after 9 years. Okay, so the setup is the same. Okay, 12,000, that is my initial amount. What's my percentage? 4%. Now, when we're going to plug it in the problem, I would go ahead and say 0.04. Remember, you got to convert that percentage to a decimal. Okay. And then it tells me we're looking for the amount of the investment 9 years later. Okay. So here is my general form. So I'm going to say f of t is equal to 12,000 times. Now, I need 1 minus 0.04. So what would that be? Okay. 0.96 to the power of t. So for problems like this, you can kind of look at it from two perspectives. You can look at it from the viewpoint of the problem where you're losing 4% of the value each year. Or from your base, you can kind of look at it from the perspective from every year that passes, you're only keeping 96% of the original value. Okay. So, there's kind of different ways to look at it. So let's plug it in. So f of 9 is equal to 12,000 times 0.96 to the power of 9. Okay. So let's see what we got here. Let me go ahead and get rid of all those other ones. 12,000 times 0.96 to the power of, what was that, 9? So what should I get when I push in? So $8,310.41. Okay. So 8310.41. So I'm going to come on back over here. There we go. So in 9 years, it lost almost $4,000. Hopefully you'd sell it before then. All right. All right. Well, let's try number 4. You ready for one on your own? Of course we are. Mark bought a brand new car for $35,000 in 2008. If the car depreciates, so that's just another way of saying that it's going to be losing value, in value approximately 8% each year, write an exponential function to model the situation, then find the value of the car in 2015. Okay. So run through this problem, identify your key parts, plug them into your function, then you can use that to answer your question. And this is actually true if you purchase a brand new vehicle, like let's say the vehicle is going to cost $20,000, the exact second you drive it off the lot, it's already lost at least $2,000-$3,000 in value. It's insane. Yes, okay. Perfect. Perfect. There we go. Okay. Yeah, that's right. Okay, well, let me go ahead and catch up real quick. So let's see here. F of t. So how much was the car bought for? 35,000. Okay. So it's going to lose 8% each year. So we're going to change that to a decimal. 8% is 0.08. But because it depreciates, it's losing its value. That's why we have 1 minus. So my base is a point. Oh, okay. Oh, okay. Gotcha. Okay. And then to the power of t. So here's the general function that would give me the value over, whatever the life of the car is. So what are the number of years we're looking at? Where'd you get that? Yeah. The car was bought in 08, and we're looking for its value in 2015. So we have to take the difference. So this would be F of 7 is equal to 35,000 times 0.92 to the power of 7. And then it's just a matter of plugging it into a calculator. 35,000 times 0.92 to the power of 7. Okay. So $19,524, and I had gotten 63 cents. So I'm wondering if I go ahead and highlight it and show it, it will go ahead and give me the rest of those decimals. Okay. All right. Exponential growth and decay. How are we talking about? This is probably one of the lessons that applies directly. Like students always ask the question, well, when am I ever going to use this in the real world? This is actually applicable. In fact, what we're about to look at, the average person, no. But the fact that you know that makes you a better person.
This reminds me of whenever my mom taught me how to figure out how much something is worth when there has a discount.
Yep.
You multiply it by the percentage, like that's and whatever you get, that's what you're getting off.
There you go. Okay. It's really cool. Okay. Now, let's talk about compound interest. Occurs when interest is calculated on both the principal and the accrued interest thus far. So basically, on those previous problems, we were only applying the interest once a year. Like maybe on January 1st, never the rest of the year. Okay. So here's my formula before I get a little too far into it. A equals P times 1 plus R divided by N to the power of NT. This is my compound interest formula. Does that look familiar to anybody? Nope, that's okay. That's all right. Okay, so P is the principal amount, so that's what I'm starting with. R is still your percentage. That's the rate that you're getting or you're losing. Now, N, this is the number of times that you're going to compound it yearly. What that means is the number of times within a year that the percentage is going to be applied to your money. Okay. So like, for example, if we go ahead and apply it, the percentage daily, how many days are in a year? So N would be 365. If your percentage was compounded monthly, then it would be 12 times a year, and so on. Okay. But here's what you got to realize about this. Okay. Let's say, for argument's sake, and this is not going to happen, but let's say you go to a bank and you have to go ahead, you're able to get a savings account maybe with, let's say, a 12% interest rate. Okay. That's really good. You're not going to get anywhere near that in today's market. But let's say we are going to go ahead and compound it monthly. Okay. So here's what a lot of people don't understand in the very beginning. Okay. It's not 12% each time you compound it. It's a portion of that because at the end of the year, it has to add up to 12%. So if we're going to go ahead and do it monthly, you're only getting 1% in January. Then you'll get another 1% in February, and so on and so forth. Let's say we were going to do it biannually. So that means only twice a year. So that means within one 6-month period, you'd get 6%. The latter half of the year, you would get the other 6%. It's at the end of the year that you total those up. That's the full percentage that you're getting. Does that make sense? I'm sorry? Yes. You got to divide by the number of times you're going to compound it. That's why compounding continuously, and here's what you have to understand, compounding continuously, that means that interest is going to be applied to your money every second of every hour of every day for as long as it exists. That's true. That is going to give you the biggest yield. It's going to have the biggest return. But one thing a lot of people don't realize is the more you compound it, the larger that number gets, the growth slows. Because think about it, from 1 second to the next, how much time has that money really had to grow? 1 second, it's like virtually none. So you're not gaining anything. You're gaining a little bit because it's positive, but the gain starts to slow the higher you go. Does that make sense? Okay. All right. And then, of course, T is time. Okay, well, let's try one of these problems. Let's see what you think. So it says Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay, so every 3 months. So that means that N is 4. Because think about it, you're always doing it on a year scale. Okay, if you're only going to do it quarterly, okay, well, 12 divided by 4 is 3, so that means every 3 months. So that means 4 times in a year. Is everybody okay with that? Okay. What's P? What's my principal amount? Okay. My interest rate is 8%, and then my time is 5. See, it's just like the previous problems. The formula is different, but you're just identifying all the items, and then we're just going to substitute them in. Okay. So my amount is going to equal, we're starting with $12,000 times 1 plus. Now, I need R divided by N, but remember for the percentage, we got to change it to a what? A decimal. So in the numerator here, this would be 0.08 divided by, well, quarterly, that's going to be 4 times a year. Now, the power is always a product of the number of compounding periods and your time. So in this case, it's going to be 4 times 5, which is 20. So what this means is that over the entire life of the investment, okay, over those 5 years, you're going to have interest applied to it 20 times in total. Okay. Well, the more you compound, the bigger the return you're going to get. Okay. But you're going to be surprised to find that it's not that much bigger. Like, I'll even prove it to you on this problem. Okay. Let's go ahead and plug this in. So they started with 12,000. How many years did it take? 5 years. Let's see what they got. So I'm going to come on over here. Let me get rid of all this. So 12,000 times 1 plus control divide. And I wouldn't even bother to try to simplify that. I would just plug it in the calculator. 0.08 divided by 4. And then we're going to raise that to the power of 20. So we started with $12,000. So in 5 years, we've gone up to 17,831. Okay. So maybe there's somebody out there who's thinking, hey, that's nice. 5 years, how much did you earn? $5,831. Yeah, so a little over $1,000 a year. Okay. Okay. Now, let's go ahead and start to play with this a little bit. Let's keep everything the same, but let's change the number of compounding periods. Okay. So here we only did it 4 times a year. Well, why don't we go ahead and do it monthly? Oh, yeah, do you have a question?
What am I doing wrong?
What's up?
Why are there parentheses not including the 1?
Oh. Let's see here. Let's go ahead and put a parentheses right there. And then we can actually remove this one right here. There you go. Oh, we also need to probably remove this one because there you go. So let's say I want to go ahead and compound it 12 times a year. Okay. Almost everything is going to stay the same. We're still starting with the same amount of money. 1 plus. Let's even keep the same interest rate. So this is going to be control divide 0.08. Okay. But now we're going to do it 12. Okay. Now here's where you got to be careful. Remember, that power is no longer going to be 20. That was weird. Okay. I'll try it again. 12,000 times 1 plus control divide 0.08. We're going to do it 12 times a year. Okay. Now remember, the power is always a product of the number of times you're going to compound it. So let's say we're now compounding it 12 monthly. Okay. But we're still going to keep the 5 years. So that's 60. Okay. So all I did was just compound it more. I went from 4 times a year to 12 times a year, 17,878. Okay. So, I mean, what did I say? The more you compound it, the more money you're going to get back. But the higher n goes, the larger n gets, what starts to happen to your money? It starts to slow. The growth slows. In fact, let's do it daily. Let's do it 365 days a year. 12,000 times 1 plus control divide 0.08. I want to take the points. Divided by 365. Okay. Now for my power, I don't know what that is right off the top of my head, so I'm going to go ahead and take the 5 years times the 365 because we're doing it daily, right? Okay. Remember, all the information is still the same. I'm still starting with $12,000, the same interest rate, 8%, the same 5 years. I went from 17,878 to 17,901. You get supersized. But that's what a lot of people don't realize with this type of mathematics. Well, you want to try to get a good interest rate, but like I said, today you're going to get really, really low interest rates. I mean, you might be able to go ahead and get between 1% and 2% depending on what you put your money into, but that's a big possibility because the bank doesn't want to risk losing any money. It wants to make money, right? Okay.
I have a question. So my dad's underwriting for, and it's just high, so it's bad for like. He says like it's like interest is bad for some people, it's good for others, like back in business. When it's high, is it good for consumers? Is it good for
Not really. I mean, it's good for the business,
business?
but it's not good for the consumer. Because like a lot on, I know that was on the campaign trail, something that was brought up, like the interest rate on credit cards. That was, last time I checked, was like 17, 18, 19%. That was super high. And then you're thinking about people like nowadays, especially with things getting more expensive, like my dad, this is why I'm trying to help him out. He puts stuff he needs on his credit card and he just pays off what he can as we go. But that is constantly accumulating interest, more money that he has to pay back. That's the big problem that people are having with the student loans, for example. It's not that people aren't wanting to pay back their student loans. we took out the loan, we're going to pay it back. The interest is killing people. That's what's hurting.
Recently, because of the COVID, all the interest rate fell over because people started to buy more houses, and after the COVID happened, interest rates started to go up, like
Hmm.
about like 7.3 or
Yeah.
8.5. For my dad and we bought like at the same time. Right now, we have to pay like about like $500,000 for a $300,000 house.
Yeah.
So by the
So you
time
end
we
up paying a
finish,
lot more.
by the time we finish, it's gonna be like for like $800,000.
Hmm. Like in my mortgage payment, for example, my monthly mortgage payment, my actual payment on the house is actually really small. The majority of that payment is going to be insurance and the interest.
That's how the banks and people can
Yeah.
pay the majority.
So it's really good to know about this. Like, has anybody had maybe a relative, maybe a grandparent or somebody set up some kind of fund for you? They started it maybe when you were born, and it's
Yes.
this is that exactly what we're talking about. Maybe it's not a bad idea to look into it, see what you got.